Okay, in this video, we'll consider the Taylor series expansion about x equals 0, so for sine of 5x. To do sine of 5x, we first recall the Taylor series expansion for sine of x. The expansion for sine of x goes x minus x the third over 3 factorial plus x the 5 over 5 factorial minus x the 7 over 7 factorial, and so on. You'll notice that all of the exponents here are odd. And you may recall from pre-calculus that sine of x is described as an odd function that has symmetry about the origin. And the reason the adjective odd was chosen was because the Taylor series expansion for sine of x has all odd exponents. This can be written more succinctly: summation n equals 0 to infinity. I have alternating signs going plus, minus, and that's captured with a -1 to the end here. If n equals 0, it starts positive. I also have a fraction. The denominators here are the odd numbers consecutively, so 2n plus 1 factorial, and then we have x to the 2n plus 1. And so that is the Taylor series expansion for sine of x. To get the Taylor series expansion for sine of 5x, everywhere I see an x, I replace by 5x. So summation n equals 0 to infinity of -1 to the n times 5x to the 2n plus 1 over 2n plus 1 factorial. And following convention, we'll set apart the x part in the numerator so that I have x to the 2n plus 1. This part of the power series is separate, and then whatever else is being multiplied, that is also separate. So again, logically, it's not required to do this. It's just the way that we typically write a power series. We'll have the x's separate, and then everything else is written on the side.